Software-defined networks, or SDNs, reduce costs and increase flexibility through open programmable networks based on commodity hardware. Combined with containers, they provide the flexibility to achieve large scale while ensuring security through isolation. Containers are lightweight enough to allow each host to support many more instances than with virtual machines. SDN supports this scale by avoiding limits like VLAN IDs, excessive broadcast traffic, and inflexible network hardware. Software-defined networks allow faster, more flexible, and more responsive network configuration through dynamic flow programming. Orchestrating containers at scale requires quick network reconfiguration, which SDN helps provide through the use of Layer 3 only networks and simpler kernel network setup. Because of its flexibility and centralized management, an SDN can more efficiently segregate containers without multiple kernel interfaces. Isolated networks that span hosts or even data centers can be quickly created as containers are spawned and destroyed. The default Docker network model uses a Linux bridge and a vEth interface pair for each container. Network address translation is used between the bridge and the host network interface. This architecture does not scale well to many containers. A software-defined network, on the other hand, connects all containers on a host to the same vSwitch, providing flow-based isolation and a shorter network path. In the following example, we'll use Kubernetes with some upcoming changes that Red Hat is evaluating to create multiple containers for 2 tenants and take advantage of container isolation with the Open vSwitch SDN. Using Kubernetes namespaces, we'll create containers for the first tenant. You can see all 4 of the first tenant's containers are now running. Next, we'll create containers for the second tenant and check their status too. Now that both tenant containers are running, let's inspect the first tenant's container by attaching to it with Docker. The container has one interface with 2 IP addresses. The first 10.244 address is a public one, while the second 10.246 is an address for private pod communication. The second tenant also has containers running on the same host. Its containers get a private address in the same range as the first tenant, but as you can see, the first tenant's IP address cannot be pinged from any of the second tenant's containers. Isolation is achieved through the use of dynamic OpenFlow rules to ensure traffic from one tenant cannot be seen by another, and that tenants can cross hosts through use of VXLAN tunnels. Combining software-defined networks and containers can reduce costs, increase flexibility, and deliver massive scale. And in this video, you've seen some upcoming technology Red Hat is evaluating to deliver isolation-ready containers networked with SDN.